Respirators. Nobody likes or wants to wear a respirator. They've been around since the turn of the century. Probably the first respirator was a damp handkerchief tied around your face. And just like the respirators today, their purpose was to clean the air you breathe. There are many different styles, types, sizes, and shapes of respirators available today. But this video will focus on the most common use, protection from silica dust. We hope it helps you to understand how important your respirator is in protecting your health. Respirators, your last defense.
Hey, George. Hey, you got a minute? Hey, this is Joe. He's just getting started here. We had a few questions about respirators.
Let's talk over here.
Now, the primary means of controlling silica dust is in engineering controls. Now, this is like ventilation systems, dust collectors. Now, these pieces of equipment, they help keep the dust from getting into the air. But there's also other controls that we need to use, such as limiting the time that you're in a dusty area. Also, good work practice. That's very important in controlling silica dust. Now, MSHA, that's the Mine Safety Health Administration, they say that while required engineering controls are being installed, workers also should wear respirators. Now, under the Mine Act, MSHA, they are responsible for the health and safety of all America's miners. So they're the ones that regulate how we use respirators on the mining properties.
Also, MSHA says respirators can be used for occasional entry into hazardous areas like confined spaces or in situations where engineering control measures have not been developed. We also use respirators in combination with our engineering and other control measures to provide even more protection than is required under MSHA regulations. It's currently not possible to measure instantaneously the amount of silica in the air that you breathe. We don't want anyone to even have a remote chance of getting silicosis. It's for that reason that we sometimes use respirators as a backup to our engineering and other control measures in some operations.
Well, let me ask you a question. Could I use any respirator to paint my car?
No, most of the time we only need protection against dust at this mine. Other hazardous materials like vapors from painting require special filters and canisters approved for that hazard. It's important to know that respirators that filter dust cannot supply oxygen or provide any protection where there's not enough air. They also can't provide protection for any contaminants other than those for which they've been approved. You should always know the limitations of your respirator. Now, here at this plant, your primary exposure will be to silica dust.
Now, most of the dust generated in this plant's from crushing or grinding rock, loading trucks, screening, other material handling. Now, the ore that we handle contains silica. Now, the other types of mines, their ore may contain other hazardous materials. And that's why the company sampling program analyzes the ore to understand its potential hazards. You should always know what you're handling.
That's right, Bill, but our primary concern at this mine is dust that's small enough to get inside your lungs. Dust that is normally considered small enough to enter the breathing system is called respirable dust. We have many processes in industrial sand plants that generate dust particles. These particles cannot be seen by the naked eye. However, if there are many of these small particles, it may be possible to see them in a beam of bright light.
Just remember, just because you can't see the dust, that doesn't mean it's not there. That's why we take dust samples. Now, the dust samples determine what parts of the plant, if any, could be a problem, and if they require additional dust control and respirators.
First of all, we only use respirators approved by NIOSH, the National Institute for Occupational Safety and Health. Come inside, I can explain it better in there. NIOSH is the government agency responsible for approving and testing respirators used by workers. The respirator and the filters must be marked as NIOSH approved. The filters must also be marked as approved for particulates if we use them for protection against silica dust. Now, we consider a lot of different factors. Not only must the respirator match the hazard, but it must also match the task to be done, and the worker too. Some of the primary factors we consider are the nature and characteristics of the hazard or hazards, the environment where the respirator will be worn, the tasks that need to be done. Next, once we know the situation, we can choose the type or design of the respirators. For respirators like this one, which filter the air, the two key features are the facepiece and the filters. For respirators like this one, which filter the air but also moves air into the facepiece, you also have the blower to consider. This type is called a powered air purifying respirator. All respirators can allow contaminated air to flow in if they don't fit you properly. However, you'll be hearing terms negative pressure and positive pressure respirator. These terms describe design characteristics of the respirator. All respirators where your lungs cause the air to move through the filters are negative pressure. If the respirator has a motor or an air supply, it can be either a positive or negative pressure respirator, depending on how it supplies the air and how much air it supplies. In a positive pressure respirator, the contaminated air can't flow inward around the facepiece seal when you inhale because it has so much air going into the facepiece from the blower that the air can only flow outward. However, if you've not been fitted properly, even a positive pressure respirator can leak inward because the blower can't compensate enough. There are three types of face pieces: quarter masks, half masks, and full face pieces. These face piece designs, as well as how the air is filtered and provided into the respirator, are used to determine the assigned protection factor, or APF as we call it. The APF helps determine the maximum dust concentration in which the respirator can be used. A good rule of thumb for face pieces is the more the face that's covered, the better the protection. The filters also have limitations which determine the maximum dust concentration where you can use them. For particulate filters, there are three types: N, P, and R, each with three levels of filtering efficiencies: 95, 99, and 99.97%, which we round off to 100. So it's called the 100 type. Some particulate filters are affected by oil and lubricant in the environment. The N-type filters are not resistant to oils, cutting fluids, glycerin, and other lubricants. Our filters are resistant to these materials for only one shift. N and R filters must be thrown away after one shift or as specified by the manufacturer, unless there has been scientific testing to show they can be used longer. P filters are oil-proof and can be worn for a number of shifts until the filters become difficult to breathe through or they get damaged or soiled. Depending on the work situation, you could wear any of the 9 different filters for silica. For ground silica operations, NIOSH recommends the use of the 100 series. It's the most efficient for removing small silica particles in the air. We've already completed the selection process for our hazards, and we generally use half-mask negative pressure respirators with P100 filters. We always use the 100 series here, but you may get an N, P, or R series based on the working environment.
Well, you talked about the respirator fitting the hazard or the task, but how will I know the respirator will fit me?
Well, we'll determine if you're able to wear one by first having our doctor make sure you don't have any physical or medical problems that may interfere with your ability to wear a half-mask negative pressure respirator like this one. Sometimes a previous facial injury or an existing lung condition may disqualify you from wearing a negative pressure respirator. However, you may be able to use a powered air purifying respirator. There are so many types of respirators to choose from that generally, if you are physically able to perform the work, you shouldn't have any problem finding a respirator of some type to use.
Well, is that all there is to it?
Well, Joe, the next step is to make certain that the face mask fits your face so that contaminated air doesn't leak in around the edges.
Right. Suppose, Joe, that the results from the doctor are in, and the doctor's determined that you're able to wear a certain type of respirator. Now we're going to select the individual respirator and make sure that it fits your face. This is called fit testing.
Well, why do you do that? Does one respirator fit everyone?
No, not everyone's face is shaped the same, so one size or model of a respirator will not fit everyone. Each manufacturer has different styles of face pieces and cartridges, just like car manufacturers. There's lots of styles and shapes. In addition, they all make a number of sizes for each model. We have to find one that fits you best. Although most people are sensitive about anything that touches their face, a properly fitted respirator is also the most comfortable. There are two basic kinds of fit testing: quantitative and qualitative. The type of fit test determines your assigned protection factor, your APF. Quantitative fit testing requires specialized instruments operated by trained individuals to determine how well your respirator fits your face. It actually takes a measurement of conditions inside and outside the respirator and compares them to determine your personal fit factor. Qualitative fit testing relies on your ability to either taste or smell a test agent such as banana oil, saccharin, or irritant smoke that's sprayed outside your respirator. If you can taste or smell the agent, you are not getting a satisfactory fit. Qualitative fit testing is not as sensitive as quantitative fit testing, so you can only get a fit factor up to 10. For us, this means you can only use this respirator in dust concentrations up to 10 times the exposure limit, even if the cartridge would allow a higher concentration. For example, if the exposure limit for the dust is 0.5 milligrams per cubic meter, then you can wear the respirator in areas that have as much as 5 milligrams per cubic meter of dust. If you need more protection than 10, you must have a quantitative fit test. It's also important that fit tests follow a recognized procedure. Even though the qualitative fit test relies on taste and smell, you can't use just anything. There are specific procedures that must be followed in order to ensure you get the right fit.
Well, what kind of fit test do you use here?
We do qualitative testing, which is the most common type used in our industry. Our potential exposures are well below 10 times the exposure limit. Now, before we actually do a fit test, you'll need to pick out a respirator here that you think fits your face best and feels comfortable. Once you've selected the respirator, try it on. Adjust the straps, wear it for a short time, see how it feels. Next, you would do a series of movements and talking exercises to simulate your movements during the workday. If you don't get a good fit, or if the fit test shows leakage into the respirator, we'd have to try another size or type. So pick a respirator that you might want to wear.
Is there anything I have to do to prepare for a fit test?
Well, yes. With a tight-fitting face piece, you must always be clean-shaven where it meets your face. That's because facial hair in the sealing surface of the respirator, or near valves, can cause dangerous leaks. Now, this is true whether the respirator is positive or negative pressure. The only types that can be worn with facial hair are those with hoods or helmets which do not have a sealing surface on the face. This valve keeps the contaminated air out of your face piece when you inhale. Anything that can prevent it from laying flat and functioning properly, like hair, can cause you to be exposed.
Well, what if I take the test and there is a leak? Then what?
First, we would check the position and tightness of the elastic bands that secure the respirator to your face. These should be reasonably tight and in the correct position on your head. We'd also check to see if the respirator was in the correct position on your face, not too high or too low. And since facial hair can interfere with the seal of a respirator to your face, we would check it to make sure you had a good seal. If the respirator still didn't fit or was uncomfortable, the next step would be to select another respirator and then repeat the test. We'd continue this process until we found a mask you could wear and pass the fit test. You would not be allowed to wear a respirator on the job without passing the fit test. By the way, you're scheduled for your actual fit test before you start work tomorrow morning.
But Joe, to make sure you're getting a good fit out into the plant, you must also do a field check every time you put your respirator on. Now, the type of fit check you do depends on the type of respirator you have. It's a quick but important check you must do every time you wear it. Now, for the type that we use here, you must do a negative and a positive pressure check. You simply inhale with your hand covering the filter. You should feel the mask start to collapse. You can see that right now. The collapse means that the mask is working properly and doesn't leak. The next step is to cover the exhalation valve and blow out slightly to see if you can generate a positive pressure inside the mask. If you detect leakage with either of these tests, adjust the straps or reposition the respirator on your face and repeat it.
Well, who takes care of the respirators?
Well, MSHA requires that the respirators be selected, used, and maintained according to the ANSI standard for respiratory protection, Z88.2, as specified by the standard. ANSI is the American National Standards Institute. This standard requires that we establish a maintenance program which ensures that you have a clean and well-maintained respirator. It allows you or somebody assigned by the company to do the respirator maintenance. Whoever does the maintenance must be properly trained and follow the company's program for cleaning and sanitizing, inspection for defects, repair, and storage. At this plant, everybody is trained to maintain their own respirator. After you're fit tested, you'll be trained on how to care for it.
Well, in general, how do I take care of my respirator?
Well, it's important that your respirator be cleaned and sanitized daily to prevent the buildup of germs and contaminants. Also, you need to check each part of the respirator, the facepiece, straps, valves, etc., each time before you use it. The flexible rubber parts, such as the facepiece, must remain pliable to conform to your face. If any parts are defective, worn, or missing, they must be replaced before you use the respirator. Now, make sure that replacements are from the same manufacturer. Don't ever substitute parts from another style or manufacturer of respirator. If you have any questions, come see me.
How about when I'm not using it?
That's a good question, Joe. You should store your respirator in a manner that keeps it from becoming damaged, deformed, or dirty. Also, keep it away from excessive heat. The supplied bags or even Ziploc bags come in handy for keeping it clean. It's a good idea to mark the storage bag so you can tell yours from someone else's. Also, check the manufacturer's instructions before marking on your respirator.
Before you ever use your respirator, you'll attend training session. This is when you're first hired and every year after that. It'll teach you everything you need to know about your respirator. Now, they'll cover in greater detail subjects that we talked about today: the hazards, proper respirator selection, respiratory protection program, medical surveillance, the limitations of your respirator, fit testing, maintenance, cleaning, storage,